let's take a look at the assignment. Maybe I should have left Miro open for a second. Because this one's definitely, it's jam-packed, right, to say the least. And the options are definitely, they vary. So like I was saying, we're making an observation tower, but we're breaking it up into different bite-sized pieces, right? So for this next exercise, is to develop the digital design and fabrication in context of architecture and to discover the techniques of utilizing the laser cutter for its speed and accuracy in model making. Our first task will be actually to select a 48 by 48 lot of space anywhere in San Antonio. And of course, I've also attached the link that seems to be actually kind of hard to, anyway, let's post the link over here. Have it for us. It's called, GIS San Antonio, but if you wanted to find it in Google, all you'd have to type is hydrology and contour San Antonio. But I'll go ahead and paste that link right here as well. Text and paste. So just in case you want that link to be clickable. But it brings us to this wonderful GIS map that shows us all the different contours of San Antonio. So the first thing, and please don't spend more than 5 hours just selecting a site or anything. What I would say is by default I'm going to select a pretty nice unique spot in San Pedro Springs Park. It happens to be that northeast corner where there's kind of actually a really big hill there, and it definitely has a lot of topography lines that I can use and I can trace and make a model from, right? However, some of you guys might know about CAD Mapper. However, it doesn't always work the best, right? This is probably good for like a site analysis, right? If you need to get the streets or kind of the bordering information. However, it doesn't give us the topography of that model. Same thing could be said about actually the contour map. Unfortunately, we can't just right click and export it as like a DWG or I'll actually leave that up to you. I haven't played around with it too much, but if you find a better way to use it, please of course inform the studio. However, I'm just going to take a screenshot of this piece, and of course I already did. So first things first, we have to select a site, right? Specifically 48 feet by 48 feet. Now I'm not really a stickler for this, right? We could line it up with Google Maps, we could get a measurement, we could do all sorts of things, but honestly, since it's this kind of project, it's not a real project, right? It's not it doesn't really need to be in scale even yet. However, I do want to go over at least how to achieve that. So I'm going to go over to Google Maps, or Google Earth I should say, just in case there's anybody here who hasn't actually done this. Please don't choose Trevi Fountain, that would be ridiculous. Let's go to San Antonio, San Pedro Springs Park. Whee! Sweet. Gotta love the little spin around. It's all about the spin around. So here's that location that I found in my contours map. Right there. So basically all we need is something, right? Something that we can go, okay, well, I know the measurement of that so that I can scale the rest of everything. So I'm going to go ahead and put my screenshot image, and you'll see that I've started to organize some of my stuff. So I have exercise 3, exercise 4, and again, just continuing in the same file, but again, to remember to be quite organized. So I'm going to just type in picture. So of course I can put that PNG, desktop. I believe it's this. No, it's not that. No. However, that's clever too. Where's my screenshot? There it is. So I'm just gonna make it, whatever, because I can always size it down. But I need something in here that I can basically align to. So in my case, I might actually have to use the streets. I might need a bigger screenshot to actually, get some of that information. But for instance, I could take this piece, obviously add a measurement, find something that is at least, it honestly can be anything. I just need to line them up. However, I'm gonna fake it till I make it for this tutorial. So like for instance, I could take the street, and it doesn't even matter how, again, 16.82 meters, perfect. I mean, that's literally all I need is just some sort of measurement. However, if you don't like looking at meters, you can go to nautical miles, Anyway, let's go to feet. Yeah, that's about 55 feet. Sweet, right? So again, I don't even really need this screenshot and overlay it. Again, I just need that number so that I can know how big to make this. Now, even though I should get a bigger screenshot, I'm just gonna fake it till I make it today. I'm gonna go with here to there is about 55 feet. So I'm gonna go 55 feet, symbol, enter. And would you look at that? I mean, it's pretty darn close. Anyway, I'm gonna assume, at least for today, that is in fact to scale, right? So the model that we're actually gonna make is only 48 feet by 48 feet at 1/8 scale. So this ends up being actually a 6 by 6 model. As you can see here, guys. 6 by 6, right? So essentially we're making this guy, but we're making it at 1/8 scale, right? So let's check it out. As you guys know, in the digital realm, we want to make everything 1-to-1 scale, or true scale is what it's known as. So let's go ahead and get our 48 by 48 square and just see how big that is. 48 feet by 48 feet. And as you can see, it's not very big, right? In fact, your pavilion is barely going to fit in that 48 by 48, right? But again, we're not trying to make a site model here and kind of get this whole thing. We just want to place it somewhere interesting. For instance, what do we know about a lot of lines pushed together in topography? That is highly sloped, right? We can basically assume, and actually we don't have to assume, but each of these lines actually indicate a foot of drop or of rise. In our case, since I know this spot so well, it's definitely dropped from the street into the park. And it's actually quite wild when the water starts to run. But so I'm basically going to select an area. Like I said, this isn't like a studio project or anything. We don't have to be too conscientious. But if you want to make an interesting model, go with more topography change, right? For sure. So I'm going to kind of choose half and half. I'm going to go with a little bit up here, a little bit down there, and that looks pretty safe to me. I'm going to go ahead and make a copy because I might want to save that for later or something. Or maybe I want a different selection. Maybe that one doesn't work out for me or something. So I'm going to take that curve, I'm going to trim, and get rid of the rest of the image, right? Next thing I need to do is basically trace it, right? So I'm going to go ahead and lock this. Lock. I'm going to go ahead and get my lines. And I'm going to make sure that I go outside of this bounding box. That way I can trim them off as necessary. So I'm going to fake it till I make it, get relatively close. Yeah, those two lines are together, is basically what that pixelation means. But we're definitely adding some resolution to this. We'll say those are really, really close. And as I can imagine, this might be a review for even some of us who have actually already even traced. Whether you've been in my graphics 2 class, this is definitely something we do. Or maybe even in a graphics 3 rotation. Could be definitely found there. It's what I'm doing with my students next. But we do need to get every line, right? And again, as you can see, I'm kind of just, again, kind of faking it till I make it. After all, this is just an exercise, right? It's not like, it's not something that I would even put in my portfolio as a project. I would actually put it in my graphic communications. I'd put it with all my other graphic stuff that I did in graphics 1, graphics 2, 3, 4, and computer graphics. Okay. So keep in mind, the goal of the project, right, is to honestly show off our skills. And show off they do. This looks like it's going to be the same. And as you can see, it does take a minute or two. However, I'm just hitting spacebar and redoing that piece over and over again. So I'm going to unlock that image. I already have a copy of it, so I don't really need this one. But voila, right? We have something that at least somewhat resembles that original image. So I'm going to go ahead and trim off what is not needed. And again, this is just so I can make sure that the lines actually get to the frame. That's why I kind of draw or trace sort of outside the line. Because again, I can always go back and trim it up. Nice. Enter. Sweet. So we have our 48 by 48 piece of land. And essentially we need to make this into a digital model first before we can send it to a laser cutter. And I say send it to a laser cutter, but that's actually really easier said than done. So a couple of things we need to do. First, let's make this actually a three-dimensional model. So it looks like it, of course, in 2D, but in 3D, of course, it's still flat. Right? So let's go ahead and hyper focus on that. And yeah, definitely flat. So we basically just need to establish a 0 point. So I'm gonna claim that this is my 0 line, if you will, the edge of that. So I'm gonna say this goes up 1 foot, right? So what I of course like to do is use multiple sides, and there it is, right? So I'm gonna go ahead and type in M for move. You can also type in all move, but there are some shortcuts for some of these. 12 inches, enter, hold shift, click, awesome. This one's gonna go up 2 feet, so I'm gonna hit spacebar. 24 inches, enter, spacebar. And I can click really anywhere because it's, 3 feet from there. So 3 foot symbol, hold shift, enter, and so on and so forth. But as you can see, it's starting to become that three-dimensional model. Okay, so 5 feet. Enter 6 feet. And again, you can almost do it without looking at even the line. There it is. Enter 7 feet. It's quite the drop. 8 feet. Realistically, we can do this out of cardboard because cardboard is already 1/8 inch thick. It already represents a foot. So, some of the ones around us are actually chipboard. You're welcome to do it in chipboard. However, you might need a lot of layers to make that 1/8 scale, effectively. Again, it is not a studio project, so we don't have to be super accurate. But if you want to test cardboard laser cutting and chipboard laser cutting, you're definitely open to some changes. Was that 8 feet? Let's try. Move. Lost track. Was it 9 feet? Yeah. Sweet. But yeah, there is at least sort of a wireframe of our model, right? So the next thing I could do is actually, there's actually a few things I could do, but I'm going to try lofting first. Sweet. That gets most of it anyway. What could I do to get the rest though, right? So I do want to get the rest, but I might have to do it in 2 parts. That's fine. So I'm going to go ahead and leave it loose. I think it looks a little bit better loose. It's doing okay. Let's check it out in rendered mode. Oh, I can't do that while I'm going to go ahead and rebuild it and make it a little stronger with 55 lines. And as you can see, that definitely gives it a higher resolution. Not too bad. All right, definitely workable. Let's test it out. Yeah, not too shabby. However, it does seem to be missing some pieces, so let's get those pieces. A couple of ways we could. I could also just, draw it in and, kind of replace it there. So I could take that curve, right, and, even line it up with another. Or I could fake it till I make it. And do a piece like this. let's see. Let's get that piece. There, there, and there. That way I still kind of get the slope in there. It's not just like suddenly flat. So I'm going to take those two lines. I'm going to join them. And let's see, what could I do? Could fill it, cap it. Let's go ahead and extrude. Again, I just want a surface, so I'm going to cap that. If it'll let me. It is an odd surface, so let's see if it caps. Doesn't want to, that's okay. We'll take that piece again. Nope, doesn't want to cap it. Let's surface it out. Could fake it till I make it. Right, put those two together. However, there's still a piece in there. Let's try again. Or, you know what I could do? I could draw the next line. I guess I could make it flat. It doesn't matter. Let's go in our top view. Point. Don't want it to line up with that, so I'm going to turn this off real quick. So disable all. And turn it back on. So I can attach to that one. Perfect. That way it actually is flat. And I guess that's okay. You'll notice that you can't cap a lot of things when there's sort of oddly, sort of an odd angle or something like that. There's ways around it, but I don't feel like going super advanced today. Where the hell did my curve go? Oh no, I deleted it. That's why it's gone. Well, I kind of need that curve back, so we're gonna have to go backwards. Let's take that curve, go back, back. Well, we got the other piece too. So let's do this a little bit easier actually. Let's just make another line and trim it off. Let's try that again. Put a line out here so it does whatever, and we'll put a line out here so you can see what that does too. I'm just trying to get it to honestly be an easier situation for us. So this one needs to actually come up 10 feet. But I'm basically lofting outside of that square so I can basically trim it off. So let's move that. Let's go 10 feet, enter. And let's go ahead and loft those together. Except that one. Better, closer, loose, rebuild, awesome. We get most of it anyway. Yeah, there's a little piece. Obviously, you know, I could stretch it out too. Yeah, I could fake it till I make it. Just go like that, right? To my surface. Not a huge deal. Right? Just want to be able to wire cut this. However, I can't wire cut it yet because it does need to be an offset surface. And let's choose the other direction. And that doesn't really matter how big it is, but let's go with 12 inches. Enter. And it does it flawlessly. So let's go ahead and trim that, or wire cut. Nice. Time to wake up. Sweet. Now we have a pretty doable piece. However, hilariously enough, we didn't necessarily have to do this either. So for instance, what I could have done was simply just take this and turn it into piece after piece after piece, right? So let's talk about that a little bit too, because I do want to show two different ways of doing this. You can model this, right? And why would I model this out, guys? You guys know? Why would I model this? So that I could use it for a digital rendering, right, of some sort, maybe a perspective. Now, I don't necessarily need that for this assignment, but I did want to show you to do that because, well, I may ask in assignment 6 to make, a three-dimensional view of that topography. So, of course, lofting, and as you can tell, it took us a little time to kind of figure that one out, but it's all right. The next thing I could do is actually set up my laser cutter first. So do you guys know the range of the laser cutter? 12 by 24. Okay, so 12 inches by 24. And what's really funny is that, well, it's in true scale, right? So it actually is that small, right? Because of course this is actually a 48 by 48 piece of land. So I really just actually need to keep that ratio. Or I could literally make it 24 by 12. Just don't lose it, right? It's a nice tiny little piece. The reason that's so important though is because, well, eventually it's actually going to be the actual size. So we do need to either keep the scale or we need to keep the ratio, right? Hopefully that makes sense. I'm going to show it again both ways, not to confuse you, but to, of course, show you that it is possible. So we also have our 2D model here. Well, actually this one's 3D, so let's make 2D real quick. Nice. And kind of pull it off to the side. So we have our original 3D and our 2D version. And we basically need pieces to overlap this, right? If we know this is our bottom piece and we know this is the top piece, we know actually this is our bottom piece, right? We need a base. So, well, that's not going to fit, but we know at scale that this is going to be a 6 by 6. So what I could do is, of course, 2 6 by 6s equal a 12, right? Essentially, you should be able to fit 8 pieces per sheet. Right? Go ahead and delete that one. And basically all I need to do is set those pieces. So my first piece will be actually the whole, but then this little piece is cut off. So of course I'll make a copy. And I'm going to select my base point, right? And let's go ahead and make that a little bit bigger. So, bam. You see how that's our first one? What I could do to kind of further make it perfect is trim off the pieces or the parts that I don't need. Does that make sense, guys? Right, so there would be my first piece. Let's go ahead and get my second layer, right? So this is kind of hard to describe, but there's my second layer, right? So I'll copy that piece. Again, choose a base point. It just has to be, something you can line with. Boom. And we have that second piece. Need our third piece. So this might be the option that a lot of us take, right? Because let's face it, I can make all of my pieces pretty quickly. However, that's great for modeling, not so great if I need a digital rendering of this. So of course we have both ways. Take that piece, so on and so forth. And then you'll find that actually all of this is getting cut off. So I could actually probably use some of these smaller pieces in there, right, to save on material. So on and so forth. And it looks like we can actually fit everything on one piece of chipboard or cardboard. Because let's face it, this last piece that I need is this hole. So for instance, also an easy way to do this too is just make multiple copies of this. Like I said, there's like 15 ways to do the exact same thing in any program, to be honest. I can get that last piece, and I can put it where, I know it's not going to interfere with already my other piece, so I need this side, and I can put it here, right? And the laser cutter will cut out this funky piece, but of course I don't actually need it for the model. But yeah, I could send this to the laser cutter, right? Basically 2 by 1, right? And off it goes, right? Or at least that's the file that I need. Lastly, what I like to do is set 2 layers. I like to call one a cut layer and one a raster layer, or score, right? In our case, we're not really scoring anything unless I actually want to label these, right? So another thing that I could do is text and type in 1, right? Put it there, and it'll be super, super tiny, right? And the laser cutter will cut it, right? Or raster it, or I could score it so I can explode it. Scoring goes a lot faster than rastering, and if you don't know what rastering is, just don't worry about it. We're not going to use it because it does take forever. But it might be a good idea to label our parts. Now, after I explode something, of course, I can't rechange it. So let's actually make all of our pieces first, or at least let's do the first 3. 2, 3. Right. And of course, I'd want to do it in a spot, not close to this edge, because I don't want those numbers to show up on my model, right? Again, these numbers are actually just so that it makes it easier to put together. That way I don't lose track of the pieces. But essentially, you're making a puzzle, right? So 1, 2, 3. You take each of those pieces, and of course, explode it. I'll take those and I'll turn them into a score layer. Change object layer. I believe on our laser cutter we have blue set to our, and this is what's kind of interesting about the laser cutter, is it does need to be the exact color. So I can't just kind of randomly choose a red color. I would need to actually choose the red color, and it actually has a very particular number, which happens to be FF00000. So in my case, my score line is going to be blue, so I'm going to hit apply. And my cut layer, I'm going to go ahead and make red. Oh, didn't mean to do that. Accidentally made it. Let's get the rest of them. Don't want those. Hey. And obviously change this to cut. And for some of us, this might be an absolute review. But voila, we have a topography model ready to be made. The red lines indicating that what will get cut, and the blue lines, of course, indicating what will be scored, right? Fair enough. So we have our topography model, right? Let's move on. So step 2, we can also ready the model for our selected observation towers using Boolean difference. So what in the world does that mean, right? Well, there's something, this is kind of just sort of a base model, right? I could basically build on it and I could cut it myself. However, some of you guys have structure that you could actually interlock into your platform, right? Or this topography. So maybe we actually want to do that. So in my case, I can go back to my top model. Sorry, actually my parallel. And let's say this was actually my complete model, or at least the abstraction part, right? So I'm going to go ahead and group it together so I don't lose track of things. This could be also where you want to put your stairs and your abstractions together. So I'm going to go ahead and make a copy and start taking a look at it on site, right? So that's kind of nice that I made a 3-dimensional model. Kind of worked out for us, didn't it? Awesome, right? So I can definitely put it in the ground or something like that. However, now I can really think about my stairs, right? I might think to myself, yeah, maybe that's too low. I can of course change a few things. I could also make, some of my structure higher. Nicely enough, I can get rid of also things that I no longer need, right? So pieces like this, obviously I'm not going to model stuff inside of the model. And of course get rid of any other elements that I just don't need. Sweet. However, you know, I don't want to just absolutely get rid of anything. So I can Boolean difference some objects, right? If I needed to trim off these, I could trim it off with a surface as well, I believe. So let's try trim. Pretty sure, yeah. So we can even use that surface to get rid of some elements. All in one swoop if we were actually pretty clever about it. But yeah, there we go. Enter, exit, nice. Pretty flush model. However, now I might need to put my circulation in. In your case, it'll be much more finished than mine. But let's go ahead and at least put my tutorial stairs in there. Kind of like this one. I'm going to go ahead and group it so I don't accidentally move everything. And of course you can always ungroup. But what's nice is now I can click anywhere and just drag it. So that's really helpful when it comes to trying to place something, right? And as you can see, I'm doing a lot of movement. I'm getting things to go around. I should have built this to scale. Luckily you guys did, right? But let's say that was my stair and it was ready to go. We'll say we enter at the top there. And again, I don't want to make it look like I'm faking it till I make it too much, but it really is kind of for the sake of tutorial. Well, looks like I accidentally stretched it. That's okay. Make sure you get the arrows. But sweet. And actually it interlocks, dare I say, pretty well. Not too many things in the way. However, you can see my screen share is definitely struggling, which is why I'll probably get another laptop. But all this stuff wasn't running. It runs like a champ though. So, but yeah, that's looking pretty good. You know, I've got the stairs kind of to the outside. There wasn't really any requirements that I need to make this sort of inside the model, but for the sake of what you guys are about to do, try and make it fit, right? See what kind of fits, and don't take away from the stairs or ramps, but take away from your abstractions, right? If something gets in the way, you're welcome to delete it or cut a hole out of it. That way your stairs or circulation can go right through. Does that make sense, guys? So I can't really show a tutorial on that just because, well, you know, I didn't really do a lot here in terms of the abstraction or the stairs for the sake of tutorial. But what I mean is, well, you know, let's say something was going through there, well, let's make a hole, right? However, at the same time, this is a new assignment. I can always move some things around still too, right? So don't be afraid to have some fun with it. If it's not working or looking right, change it, right? Like for instance, right now, that's not looking right. So if this was the case I ended up with, I'd probably move this out a little bit, right? Make that match a little bit more, and maybe bring it back down to where it was, right? Not too shabby though. Maybe I get rid of some things that I just realized I didn't need, right? For instance, maybe this floating stair and things like that. Maybe I do want some shade elements. Maybe I do want them to sort of come up and be on this platform. Fake it till I make it, right? Nice. But push and pull, move a little bit to get things just right. However, that's looking pretty good, right? And if my professor asked me if, you know, could I get a rendered view? Awesome, it's ready to go, right? Because I made that topography model and I even used it to chop some things away. However, when I'm fabricating, I might want to actually kind of have these positions for myself into that model, right? So how do we do that? Well, good thing that we made this three-dimensional model. However, I could also just make 2D of that situation and even put them on these pieces. Does that make sense, guys? So what it would do is give me a bunch of squares. So again, let's try it two different ways. I could Boolean difference this one. So again, I'm gonna make a copy because, you know, I don't want to ruin anything. In fact, I'll make a copy and hide this one. I usually hide stuff or kind of put things off into a box somewhere. Again, it's just kind of the way I like to stay organized. You don't have to organize the same way, but you know, that way I can keep stuff. But yeah, let's go ahead and Boolean difference just these pieces. So hopefully, you know, if I layered everything correctly, I can actually just turn some things off. Make 2D. Yeah, and apparently I made that all on default like a dork, but let's go ahead and remove those columns. So I'm going to take this piece, Boolean difference, right, and basically select all of the ones that I do want to cut from the topography. Yeah, I forgot I got real fancy with the shapes, didn't I? Okay, thank God I just used squares. Otherwise that might have taken a little while. It looks like I got my columns though. I think I got most of them. Yeah, it looks pretty good. I'm gonna go ahead and press enter. And you'll see that it actually kind of made like a little indentation in there. So let's move this out a little bit and see what that looks like. Nice. I have an exact map of the location of where those pegs should be. Now, if you take a look at sort of this final model, right? So I did actually put some model requirements. Now, we're not going to laser cut dowels, right? That would be really dumb because we could just buy certain dowels at certain dimensions, right? So the topography model should of course be a 6x6 and at least the name at the bottom. Now this is where I was saying it could either be in chipboard or it could be in cardboard. The vertical circulation should be in basswood or chipwood. Columns, definitely basswood dowels, right? So we're setting ourselves up for success here. We've definitely got some of those. However, I do need sort of kind of like a map of that. So what would I do to make a map of that? I'm going to go ahead and make 2D. But I don't want to make 2D of the perspective. So I need to make 2D of that top view. That way I can get those little squares. Does that make sense, guys? Hopefully so. I know I'm going pretty fast, and you know, some of you guys are like, oh, thank God he's recording. But keep in mind, sometimes those things fail, right? So it's not ever a bad idea to continue taking notes. Anyway, let's get those pieces. Should be somewhere over there. This is why I like to watch it make 2D. I have no idea where it went. Let's try that again. Or do I have my make 2D turned off? That's why. So of course make sure that your layers are turned on so that you can see them. Where the heck did it go? Is that it? Nope. Did you guys see where it went? Where'd it go? Oh, it said unsuccessful? Sorry, let me pay attention this time. Oh, there it is. I think I probably have like 3 copies of them. Yep. Nope. But nice, right? There is the exact little pieces that I need, right? So I'll take that, copy, and I'll choose a base point that I know that I need, right? And essentially apply that. Do it over, over. Now, would I want to score them or cut them? Oh, you want to sit there and be cutting these little holes out of each one? I don't think so, right? And of course, you'll want to line up perfectly, a lot better than I'm doing. Right, because you'll realize, okay, I need the hole on there. Wait a minute, that one's actually being cut off. I don't need that hole actually here. Right, so a few of it is actually a little bit like, for instance, that. Well, I actually just need this part to be cut off. So I can trim that and get really fancy with the spices. Man, is my Discord on? That's why it's going so slow. My bad, guys. Also, too many sounds involved. But yeah, you know, we don't necessarily have to cut out the whole square there, and we can get really particular about exactly what we want to cut versus what we want to score. However, in all these little green pieces, all right, and I can turn those off real quick so I can get them all. How easy is that? Turn them back on, and I can change those to a cut layer. Sweet. So now I have something that I can even cut, right? And of course I have tons of holes that I don't actually need. And why would I get rid of those unnecessary holes? Because that's more time on the laser cutter, right? And it's more time doing unnecessary things, right? So don't leave them. Right? Plus it'll actually indicate to you, oh, this is the piece that I keep, right? Sorry, probably really hard to see. And you wouldn't accidentally want to get one of your cuts in a wrong piece either. But nice. Now we got it labeled. Now we got little cut holes so that we can put our dowels in when we glue this all together, right? Of course, on Thursday, I'm actually gonna cut this on the laser cutter. So let's get a little bit farther as we have maybe about 18 minutes left. So let's continue. Like I said, we're just making the model portion. So yeah, I'm setting myself up for success and keeping some of the model stuff. That way, just in case I need to make a two-dimensional drawing and print it out, I can. But for at least this exercise, it is just the fabrication side. So, okay, we got the topography, we got the columns, because, well, those are going to be basswood. How do I get, you know, kind of these interesting shapes, right? So let's go ahead and turn on some of those layers. And let's take a look at one of those definitely interesting shapes. However, not every single shape actually can be made. In fact, there's plenty of stuff that we can make in Rhino that just can't be made physically. However, there's definitely things that we can, right? So first things first, you know, we have some of our vertical elements, right? And I'll need to make that either out of chipboard or something, right? However, the thickness might be the thickness of something I already have, right? So let's say this was really thin. It's to scale, it's only actually an 1/8 inch thick, right? Does that make sense, guys? If this is a foot, right, the real material would be 1/8 inch thick. So one thing I could do is, well, I can either unfold this and fold it together with a very thin material, right? Maybe I could do it with Mylar. Mylar cuts on the laser cutter. What else cuts on the laser cutter? Paper. Anything, honestly, cuts on the laser cutter. I say anything, but honestly, don't put anything in there, right? Because it is limited, right? We can use chipboard, Mylar. You can actually laser cut leather. There's actually quite a few things that CO2 cutters can make. Anyway, we're going to take this out piece by piece and figure out how to make it, right? So the first option is to unroll it, right? So let's go ahead and unroll surface. And where does it go? Is my dyslexia getting to me? Unroll. There it is. Unroll surface. I'm going to go ahead and hit enter. I don't want to explode it, just to kind of show you what it does. I can go ahead and label it or keep properties, but let's just show you what it does. So I'm going to hit enter. It's going to look like it did absolutely nothing. It's kind of like Make 2D where it unrolls it somewhere else. So here's that piece. How effing cool is that? That entire piece was just enrolled and mapped. This is very similar to, have you guys ever sort of taken apart like a cereal box? Right? And it's actually a flat piece of something that's been folded and put together, right? It has little tabs and they're actually glue them together, right? In our case, well, if I laser cut this, well, first I want to take my ISO curves off, right? So there's that face, and you know, if I make the outside line a cut line and I make all these little inside lines score lines, I can theoretically laser cut this, fold it, and glue it together, right? It makes a single piece. However, if we're building at a very small scale and you already realize that, well, actually I need a piece that I can just kind of laser cut out and then just bend it a little bit, right? So I mean, there's definitely different ways. Let's take a look at the piece and kind of put them side by side, because that might be a little more helpful for some of you guys, right? But essentially, it's getting every face for us, right? It's getting this bottom face. Let's zoom in on this a little bit better. It's getting these bottom faces for us, which is actually that weird piece, you know, that's kind of just dangling. Oh, there it is. Right, that won't work, because that would be cutting a piece out of the piece that we need, right? So maybe this folded model isn't so great after all, right? However, we could explode, right, and quite literally take this piece out, right? So what's nice is it stays in kind of these surface pieces. Crisis avoided, right? Now at least this piece can be made in two separate pieces that are glued together, right? Does that make sense, guys? Hopefully so. But now we have some exploded surfaces, and as you guys know, I don't really need surfaces to laser cut. What I would need is to actually make it make 2D. So make 2D, enter, apply. It's gonna go make it off over here. Bless you. And this is more or less what I would send to the laser cutter. Now if I wanted tabs for myself that I could cut and use, I would just make little tabs. Right? Does that make sense? You guys know what I'm talking about, the little tabs that, I mean, honestly guys, if you guys have never opened a cereal box, now is your chance, right? I mean, please go home, mom, dad, sister, brother, do you have an empty cereal box that I can, experiment with real quick? Right, but basically this folding principle is highly used in the standard of everything, not just architecture, but pizza boxes. I mean, has anybody ever worked at Domino's and you were the box guy? I don't know, I was definitely that guy for a week, where I took all the flat pieces of cardboard, flipped them and folded them and turned them into three-dimensional pizza boxes, right? It really is the same thing, except in our case we're doing it backwards. We're creating those pizza boxes, quote unquote, based off the three-dimensional geometry. And again, this can seem really advanced, so again, this is why I'm trying to go a little bit slower about this. So not saying that this should be done by any point, like say next Thursday or even this Thursday, but we'll essentially need to do this for all of our pieces. However, you might run into a piece that, well, I could actually make this part out of chipboard and just bend it myself. Would that be acceptable? Yeah, absolutely. Does that make sense, guys? So I can change the thickness of the material, right? I don't necessarily need this whole folding piece. However, I think a lot of us can definitely use this in our studios, right? For maybe that complex roof that you're doing, right? Unfold it and laser cut it, right? Simple enough. Let's continue though. Yeah, we get our vertical pieces. Lastly, let's prepare the laser cutting lines, and that's of course what we did with unrolling surface. So I'll leave the stairs and how we would make those for the next tutorial. However, I do know that I went pretty fast today, so just to kind of recap it, right? We organized our files, we went ahead and made a topography surface, right? And we also talked about how we can just do it without making a topography surface as well, right? We can basically get a wire frame, right, and make it ourselves, right? We can keep it in 2D and actually extract it for the laser cutter. We can also make that three-dimensional model. That way we can actually start to rebuild it in real time. What I would say is you definitely want to rebuild a model before you make it in real life. Right? That way you can actually test and see a lot of the things that you may need to know or that collide with each other before we actually make them. Right? For instance, I might just decide this piece is too hard to make. Don't need it. Right? And I'm perfectly fine with that as well. However, as scarce as mine looks, I wouldn't want yours to be that scarce. Also the stairs, it's up to you how you want to put them in. I'm absolutely fine with them sort of sticking out of the abstraction model. However, let's not get them like, what's the best way to show this? Don't put it like outside the base of the model. Does that make sense, guys? Let's try and keep it at least on the foundation or platform, right? The topography itself. But yeah, definitely want to make it first, put it all together, right? And what I would say is if you're somebody who's finished with the stairs, definitely get those stairs in there and start making your topography. Sound good? We'll go ahead and stop it for part one, unless there's any last minute questions or clarifications of something. Any at all, guys? You stick with me through most of that? I'm sorry, it does start to get a little bit more complex, and to be completely honest, it's kind of hard to describe what I'm actually doing sometimes. To me, it's kind of just second nature. However, hopefully this recording is at least somewhat of a resource for you. However, I would say you kind of just have to go for it. You kind of just have to practice. I could show you everything in the world about Rhino, but it's not going to suddenly make you know this program, right? So as you guys know, practice makes perfect, or perfect practice makes perfection. Anyway, I'll leave it there.